Hi there. I've been working on my polar heliostat. That's the one that basically tries to direct the sunlight from the position in the sky to one point by moving a mirror along an axis of the axis of the Earth. So in a counterclockwise direction along the axis of the Earth. For that you need to have only one axis. So normally you have two axes to give the mirror an exact three-dimensional angle towards the sun. In this case, you basically have solve the problem by making the motion of the mirror, per definition, let's say more congruent or an analogous, like as the movement of the sun. I was a bit confused by the word congruous, which I think is a correct way to pronounce it. But anyway, you need an axis which is directed to the south, where the sun is, along the Earth axis, parallel to it, and then you turn it. That's what you do. And to turn it, I was trying to get these geared motors that I have, this one, to somehow do that. And first solution was very simple, which is to connect it to the axis itself. Then you would have 4 RPM, which is a little bit fast. It's not very precise. So I made up this idea that I basically mount it right here, and then I make a wire which runs over the rim of this circle. And then I get about 40 rotations of this axle before the whole thing goes from east to west. And that means that I've got really a very highly precise way to position this. So what I need, so I made the circle. I basically took a piece of wood. First I drilled the hole, then I draw the circle, then I cut the circle, and then I glued this and I screwed it on. This thing on, and it can take the weight, so it's interesting, but it does have a little bit of a problem because the rim of the circle will touch that, and I cannot remove that because that's where the wire will run. So too bad. But I'll link to a webpage about the polar heliostat, which is let's say simplified to single axis heliostat, but the other axis, which is basically the angle at which you expect the sun to go through the sky, which determines basically let's say, so in the middle of the summer it goes right to the top. In the winter it stays very low. That angle you have to adjust manually, but you could also, if you have this setup, so you have it, you fit it like this, and you basically each day it's just, it can be a very little difference, but you could make this movement, of course, also mechanized by making a little motor on the rim of this circle and having a threaded rod to connect with the mirror. Another use for this is, of course, in the two-axis heliostat, because this is a very nice rotating plateau. The only problem you could imagine that you have is that, of course, you cannot use weights easily because, of course, the wire wants to go down and not horizontally. But you can, of course, fix that by using a few, let's say, what they're called, pulleys or something like that. And then your problem is fixed, and then you can have this motor actually drive even a horizontal rotation and positioning, which is, I think, pretty interesting, because you can make this the base of a heliostat. And you can have your two-axis heliostat at the same time with the same design. It's quite old-fashioned to use wires and pulleys, but it just saves a lot of money. And what does it matter if you have to replace it every 2 years or every 4 years, because those wires are very cheap. That's why people used to use them. It used to cost a lot of energy to use, let's say, these these machines with the rolling bands, but they didn't have anything else. And maybe maybe they started to use the metal chains and all that stuff simply because the energy was so cheap. Now energy is less cheap, and certainly material costs are more are rising. So why not use technologies that do work? Uh, Especially because if it's a cheap project that you can easily do, then there's less of a well, then it's less of a step to do it. It's more like fun. Um, we're working on the whole positioning, but the nice thing with this is that you can basically put a magnet on this side and scan and put the Hall sensor next to it. So it's really, I'm going to really try to get this or next week get these two Hall sensors connected to a microchip with the magnets for the positioning. Going also because I'm now talking about these weather detection, weather air quality detection system, and it's really interesting technology, I think, to many people, and especially because you can also simply you can have this thing in your home. You can have it connected to the internet. You can have it the internet accessible on your mobile phone. You can simply push a few buttons on your mobile phone, and this thing starts turning. That would be pretty cool. Cost of that is marginal. So I'm thinking about um, taking obviously taking this earlier frame, which I not yet have motorized, and giving it away to one of the viewers here, simply as a promotional stunt. This is with a magnifying glass, but I'm not sure what I want in return. A couple of $1,000. And then it's not much of a promotion, of course. It's like you can win a prize of $5 if you give me $100. That makes me think almost like a banker. But I'm always hoping that I'm, let's say, considered to be less lazy than a bank. Anyway, there's a lot to say about economics, but I won't do it right now because this video is about the heliostat. I'll link to a page about the polar heliostat below this video so you can find out a little bit more about it. And thanks for listening, and I hope you like the whole topic and go to the websites and donate or do anything because I'd like to keep going.